going to discuss the entire ER model and the associated relational model. So we are going to talk about each and every component in this ER model and how the respective relational model will look like. So we know how we have drawn this ER model, right? So associated with every construct in this ER model, I am going to demonstrate now how this can be converted into a tabular form so that we can come up with a relational model. And once we are ready with the relational model, directly we may go and implement this relational model in one of the relational database management systems. Okay, so this is our ER model under consideration, and this is actually the relational schema that we are going to talk about. But for the sake of understanding, I have merged these two figures together. But I just want to know whether it is visible in one screen.
Yes,
Are you able to identify the letters?
yes, ma'am.
Fine. So let us try to relate the ER model and the associated relational model. And whatever may be the problem statement that is provided to you, first of all, you should come up with the ER model and then you should come up with such kind of a relational model. Okay, so start our discussion now related to these two models with the example of our university schema or university database. So let us see one by one what we have done. So in fact, whatever you are observing here in this relational model, we are having the tables with the name of the table, and we are having the list of the attributes that we may have, right? And I'm going to explain the meaning of these arrows also, or the directed lines from one table to other table that we have drawn. Okay, now let us begin with, say, this department table or this department entity set. So what are the attributes of this department entity set? We are having department as the strong entity set with three attributes: department name, building, and budget. So I am converting now this department entity set into a table, separate table. Why? Because this is a strong entity set having its own primary key. Okay, so I am converting this department entity set into a respective table. See here, department table. So name of the table is department, and the three attributes are denoted: department name, building, and budget. Department name is underlined, so this is a primary key for this department table. Very simple, straightforward. Correct? So we are done with this department entity set. See, first of all, let us look at the entity sets, and then we will see how to convert the relationship sets into the respective tables. So we are done with this strong entity set department. Now let us see how to do with this another strong entity set, that is student. So what to do with this student? So student is once again a strong entity set, right? So we should have a separate table for this strong entity set student. So we are having here a separate table for student. What are the attributes? Obviously, whichever are the attributes, those are denoted here. We should have those attributes in this table. So what are those attributes? I am having ID, I am having name, and I am having total credits. associated with the student. So these three attributes of this entity set I am having in this table. Okay, we are going to talk about this department name later. Fine. So in this table I am having these three attributes. So in this student table I am having these three attributes. Fine. Now let us look at this strong entity set instructor. For this strong entity set instructor, we are having a separate table. So we are having here a separate table instructor. So once again, what are the attributes of the entity set? ID, name, salary. So obviously, I am having these attributes ID, name and salary. These three attributes belonging to that entity set in ER diagram. Right? Obviously, we are marking whichever is the primary key. So ID is the primary key. Here, ID is the primary key. Fine. So we are done with this instructor entity set. Now, let us see one more entity set, strong entity set, say course. So course is the entity set here. So what we have done is, for this course, we have created a separate table, course. What are the attributes? Course ID, title and credit. So we are having course ID, title and credits. Okay, so we are having these three attributes for course associated with these three attributes of this entity set course. Okay, so we are done with this course. Now, there are few more entity sets as well. So let us talk about now these entity sets. So here we are having entity set time slot. Okay, now for this time slot, I am having one primary key, time slot ID, and one multi-valued attribute, day. Multi-valued attribute, day. But look at this attribute. This is not only multi-valued attribute, but this is also composite attribute. So what we mean by that? This multi-valued attribute day is having subparts, day, start time and end time. So every day is represented as day, start time and end time. Is that correct? So when converting this composite attribute into a tabular form, we need to flatten that composite attribute. Meaning, while creating the attributes in the table, we are not going to have a separate attribute for this composite one, day. But instead, we'll be having these three separate attributes. Why? Because this is composite. Also, this is multi-valued. So, according to our rule, what we need to do? We need to create a separate table for multi-valued attributes. So, we should have a separate table for this multi-valued attribute. And what are the parameters or what are the attributes in that table? We have seen earlier. Please recall back. If I am having a multi-valued attribute M, then this attribute needs to be represented with separate table. And in that table, what I should have is, I should have this multi-valued attribute along with the primary key of the entity set. So if I create a separate table for this multi-valued attribute, what would be the attributes of that table? I'll be having day, start time, end time and the primary key of this time slot. And primary key of the time slot is time slot ID. So associated with this table for multi-valued attribute day, I'll be having time slot ID, day, start time and end time. But if I look at entity set table, what I should have in this table? Once again, I should have time slot ID and the flattened attributes for this composite attribute, that is day start time and end time. So ultimately in my time slot table also I need to have time slot ID, day start time and end time. So what I have done is I have created one table for this time slot and the primary key of the time slot ID, yes, there it is, and this is the multi-valued attribute with 3 components because this is composite also. So we have stored these 3 attributes separately, day, start time and end time. Is that correct? So if I am treating this as the multi-valued attribute and having associated this table with the primary key, time slot ID and these 3 attributes. Okay, as I am not having any additional attribute of the time slot, right? I may come up with this simple single table. If I would have been few more attributes, then I would have 2 tables associated, one with time slot and one with this multi-valued attribute. But as I am not having any more attributes other than the primary key and the multi-valued attribute here, I am having a single table time slot wherein I am having this primary key, time slot ID and these 3 attributes, date, start time and end time. Okay, and as this is multi-valued attribute, I am having more than 1 entries for this day. So the primary key of the time slot table will include time slot ID, day and start time. I may also include end time, but no need actually to include this attribute into the primary key, because if I know the start time, end time is fixed, right? So no need once again to include end time in this primary key. So the primary key of the time slot would be time slot ID, day and start time. So these 3 attributes will uniquely identify the time slot in this table. Okay, so this is how I have converted this entity set time slot in this table time slot. Right? So you might have some confusion here because at a time we are having 2 concepts, multi-valued attribute, that is composite. Multi-valued attribute, that is composite. Right? So for this multi-valued attribute, we have created a separate table with primary key of the entity set along with its attributes. Okay? In fact, if I am having a separate attribute, one more or few more attributes like this for time slot, then I should have, if this is the case, then I should have one more table associated with this time slot. And in that table, I'll be having primary key, time slot ID along with these attributes. Right? But in this typical example, as I'm not having any more attributes like this for this time slot, I have combined the table for the multi-valued attribute and the original time slot table. And I'm having only one time slot table over here. If you have any doubts, please let me know. Yes. Understood? Yes. Any further clarification is required? Or understood the concept?
Yes, ma'am.
Fine. So may I proceed with the next? May I proceed with the next? Yes.
Yes, ma'am.
Fine. So now we are having here the entity set classroom. Okay. So this is once again a strong entity set with the primary key, room number and building. So I'll be having a separate table for classroom. Primary key as building and room number. So that has been depicted, and the attribute capacity. So classroom is the entity set for which I am having here a separate table. Okay. Now what remains is this entity set, weak entity set. Correct? So what to do with this weak entity set? So as we have seen, as per our rules, we should have a separate table for this weak entity set. So for this section, which is a weak entity set, I am having here a separate table section. Now what about the attributes? Attributes comprise the primary key of the identifying entity set. So which is the identifying entity set with this section? Course. So primary key of the course should be added here. So we have added course ID in section. What else? The partial key or the discriminator. So section ID is there, semester is there, year is there. Okay, and this will form the primary key for this section. All these four attributes together will form the primary key for this section. We have seen this earlier. Now, what else we should have? So these are the essential attributes, but you may observe here few more attributes, and why we have added these attributes I am going to explain you this also. But please remember, now I am going to explain why we have added these attributes a bit later, but please look at how we have converted this weak entity set in the tabular form. So by rule, weak entity set, we are having separate table. Primary key of the associated strong entity set, we have course ID along with the partial key. And if this section is having any other attributes, we need to add those attributes as well. But right now we are not having any attribute apart from the partial key attributes. So we have not added any such attribute over here. Now we are done with all the entity sets. We are done with all the entity sets. Now let us talk about the relationships, and then I'll be explaining you few of the additional attributes those we have added in few of the entity sets table. Okay, now let us see one by one the relationships. See here, in department and course, we are having the relationship set course department. Okay, but we are not having any table associated with this relationship set. So we have omitted the table associated with this relationship set course department. And the reason is, we have seen the rule. This relationship set is one to many. Towards many side, it is total participation. So what our rule says is, we need not create a separate table for course department, but instead the primary key of department should be added into this course table because it is many side. So primary key of one side should be added into the table of many side. So if you look at this course table, we have added department name here. And why we have added department name here? To denote this relationship between course and department. So instead of creating a separate course department table, following the rule, what we have done is, we have added department name, which is the primary key of one side, to the many side table, that is course. Just once again look at and please report if you have any problem, if you have any doubt. Got the concept? Why we have added this department name here in this course table? Have you understood?
Yes, ma'am. Yes, ma'am.
Fine. So now we are done with this design of course table. Okay, and we know now the reason why we have added this department name over here. Okay, now similarly we are having few more such relationships. Say for example, if we look at this relationship student department, it is a similar kind of relationship between department and student. So once again it is one to many, towards many it is total, right? So what we have done is we have not created a separate table for this student department relationship. Instead, whatever is the primary key of the entity set towards one side, that primary key needs to be added into the table of many side. So the similar reason, student table includes now department name, which is primary key of department table. Got it? Yes?
Yes, ma'am.
Good.
Yes, ma'am.
Fine. Now, what next? Let us talk about this advisor relationship. This advisor relationship is one to many. This is one to many. But please remember, there is no total participation towards many side. There is no total participation towards many side. And that is why we must have a table associated with advisor. Okay, so we are having here a separate table for advisor, wherein what are the attributes? Attributes should be the primary keys of the participating entity sets. So instructor primary key is ID, that is depicted as IID here, and student primary key ID, that is depicted as SID here. Got it? So we have created a separate table for advisor, and now we are having the primary keys of both the entity sets here. Right? Got it?
Yes, ma'am.
Now, just look at this. SID is the primary key for advisor. SID. So why SID is the primary key for the advisor? This relationship set is one to many. So one instructor may have associated with more than one students, but one student is having at the most one instructor associated, or exactly one instructor associated, not more than that. So this ID of the student, right, that is the primary key of the many side, primary key of the many side can be treated as the primary key for this relationship set advisor. I'll repeat. Primary key of many side, that is SID, can be treated as primary key for the advisor. And the reason is this is one to many relationship, one to many. So primary key of the many side, by rule, primary key of the many side can be used as the primary key for this relationship set, that is one to n, one to many relationship set. So SID will form the primary key for advisor. Okay, Now, we are done with advisor. Now, the next relationship that we have here is text. Text relationship. So, how to represent this text relationship in the tabular form? What kind of cardinality it has? It is many to many. So obviously, if it is many to many, we should have a separate table for text. And that is why we have created here a table for text. What are the attributes? The primary keys of the participating entity sets. So who are participating? Student and section. So what we should have here? Primary key of the student. So we have ID. Primary key of section. So what is primary key of section? These four attributes. Course ID, section ID, semester and year. What else? If there is any descriptive attribute associated with the relationship set, we should add that in the table. So we have added grade. Got it? So this is how we have created our table text. Any doubt? Any doubt? Yes?
No, ma'am.
Fine. So we have done with this text. Right? Now, what remains is, see, one more relationship is been remained here, that is prerequisite. Prerequisite. So, what about this prerequisite? What about this prerequisite? This is the relationship wherein this course entity set is participating twice. And that is why we have shown here the labels. So this is a role that we have seen. So one course is participating as course ID and another course would be the prerequisite for that particular course. So as usual, we should have a table associated with this prerequisite. Okay, and this relationship is many to many. This relationship is many to many. So if this is many to many relationship, we are having a table associated with this separate table prerequisite. And what are the attributes? Once again, primary key of participating entity sets. So the same entity set is participating twice. So once we are considering the primary key as course ID, another time we are considering the primary key of the course as prerequisite ID. So these two are the attributes for this prerequisite. And please see here, as this is many to many relationship, the primary key of this relationship should include both these attributes, course ID along with prerequisite ID. So this will form the primary key for my table prerequisite. Got it? Yes?
Yes, ma'am.
Fine. Now, what has remained? We are having here this section class, which is one of the relationships. Okay. Now, how to deal with this relationship section class? See here, this relationship set is between section and classroom. And if we look at this relationship set, it is many to one, and towards many, it is total participation. So, according to our rule, there is no need to create a separate table for this section class. But instead, what we are going to do? What we are going to do? We are not creating this separate table. But what we are going to do? We are going to add primary key of one side into the table of many sides. So where is the table for many sides? Section. Here it is. What is the primary key of one side? Room number, building. These two attributes forming the primary key of classroom. So what we need to do? We need to add primary key building room number in the table of n side. So n side table is section. So we have added building and room number. Is that correct? We are simply following the rules. Right? This is many to one relationship. Towards many it is total. So no need to create this table, separate table. Instead, what needs to be done? Add primary key of one side into the table of n side. Table of n side is section. So primary key building room number is being added into this table. Got it?
Yes,
Yes?
ma'am.
Fine. So we are done with this relationship set. Now, we are having here one more relationship, section time slot. Section time slot. So once again, logic is the same. Here it is many to one. Towards many, it is total participation. So once again, no need to create this separate relationship table. Instead, what needs to be done? Primary key of one side to be added in the table towards n side. So primary key of time slot ID should be added into section table. So time slot ID is added into section table. And this is how we have formed this entire section table. Got it? Yes?
Yes, ma'am.
Fine. So what has remained now? This relationship teaches and this relationship set section course. So let us see what we have done with these two relationship sets. Let us talk about this teaches. Here, teaches is the relationship that is many to many. So as this is many to many relationship, what we need to do is we need to have a separate table for this relationship set teaches. And we have here that table teaches. Right? So as this is many to many relationship set, we should have a separate table for teachers. Now, what are the attributes for this table? Obviously, for the relationship set, whatever are the participating entity sets, primary keys of the participating entity sets will form the attributes of this relationship. So primary key of the instructor is ID. So for this teachers table, we are having the attribute ID. What next? The primary key of other participating entity set, that is section. So here section is the weak entity set. So what is the primary key for this weak entity set section? It is course ID, section ID, semester and year. So partial key of section, that is section ID, semester, year, along with the primary key of the course, that is the identifying entity set for this weak entity set. So the primary key of the section is course ID, section ID, semester, year. So we are having course ID, section ID, semester and year. So this is how we are forming this table teaches. Right? It's section course. So section course is the identifying relationship set. between the weak entity set and strong entity set. So as per the rule, we need not create a separate table for the identifying relationship set, and that is why we are not having here the table associated with this section course identifying relationship set. So we are not having that table over here. Okay, so we have talked about all the entity sets and all the relationship sets present in our ER model, and we have come up with this relational model for this ER model. Okay, now only the last concept that is remained is about these directed links. So how to interpret those directed links? So we are having various tables now in our relational model, but what we have done is we are having various attributes. Those are borrowed from some other tables. Say for example, if I am having this student table, I am having department name, but department name is the primary key of the department table. So I have borrowed this department name from department table and I have used it in student. So I need to depict this particular relationship from where I have got this attribute department name, from where I have borrowed this department name. So I have borrowed this department name from this department table. So I should depict it with this link having arrow towards the primary key. So this particular key that is being used in student table is known as the foreign key. Foreign key. So this department name is not actually the attribute of student table, but it is borrowed from department. So this department name is a foreign key. So always we should have the arrow from foreign key to the primary key in the respective table. So department name to department name in department, there should be the arrow or there should be some relation like this. So department name which is foreign key in student table, that is borrowed from this department where department name is the primary key. So everywhere we have implemented this concept of primary key and foreign key. Okay. Now, if I look at this advisor, here SID is borrowed from student table. So I am having the link between SID and ID of the student. This IID is borrowed from instructor table. So I am having this arrow from foreign key IID to the respective primary key ID in instructor. Okay. Now, in this instructor table, I am having this department name that is borrowed from department. So, from this foreign key department name in instructor table, I am having this arrow to department name in department table. Okay. In this prerequisite table, course ID is the foreign key. Prerequisite ID is also the foreign key. So, course ID is borrowed from course ID or from course table. So, I am having the arrow from course ID in prerequisite table to course ID in course table. Prerequisite ID is also borrowed from the same course table. So, I should have the arrow from this foreign key prerequisite ID to the respective course ID. Okay. Similarly, from wherever we have borrowed the attributes, we should depict those relationships via such kinds of arrows. Okay. So this course ID is borrowed, or rather this course ID, section ID, semester ID, year has been borrowed from this section table. So we are having all those respective arrows. Okay. So this classroom, we are having building number and room number. So this building number in section and room number in section are borrowed from classroom table. So we are having these respective arrows. Right? So these arrows, time slot ID is borrowed from time slot. So time slot ID to the primary key time slot ID. We are having this arrow. Okay, so this is how actually we should depict these relationships in relational model by making use of such kinds of directed links from foreign keys to the primary keys. Foreign keys are the keys, those are being used in some table and these attributes are working as the primary keys in some other table. So in other table it is primary key, but if we are making use of that attribute in some other table, then we say that it is a foreign key that is borrowed from the main table. Okay. So I hope you must have understood how to draw the relational model. So in this extended session, we have covered how ER model can be converted into a relational model. I would advise you once again to go through all those concepts, very important concepts. In your laboratory sessions, experiment number 2 is related with this conversion of ER model into relational schema. So you are advised once again to go through the contents, understand the rules, right? And whatever is the problem statement that you are dealing with, you must have drawn the ER model for that, apply these rules, those we have discussed today, apply those rules and come up with such kind of a relational model. And once you come up with such kind of a relational model, it is possible that you can implement it practically. So these two are actually really very important steps in application building for database, right? So you should come up with a correct ER model. If your ER model is correct, then and then only it is possible for you to come up with a correct relational model. Okay, and if relational model is correct, then no doubt you are having a good design of your database and you can implement it. Okay, so I hope you must have understood. If you have not understood any concept, once again go through the details, right? And in today's lab session, if you are ready with your ER model, please try to apply the rules and convert your ER model into the relational schema like this. Okay, so let us conclude today's session. If you have any kinds of doubts, please feel free to ask your doubts. Otherwise, I'm going to conclude the session. Right? Any doubts? Any doubts? Fine.
No, ma'am.
So once again, you go through the contents, very important contents that we have covered today, right? And these you need to apply to come up with the relational model. Okay? So let's conclude. Thank you.